Hello students, today we will discuss about one more topic in module 1, that is Heisenberg uncertainty principle. As you know, in classical physics or classical mechanics, we can measure the momentum of a particle and also you can locate the position of the particle exactly. That means here, according to classical physics, position and momentum can be measured exactly at any time and you can measure it for the later instant also. But when it comes to quantum mechanics, since you are representing the particle with the wave concept, that is a wave packet, that is, it is through probability. Hence, what happens? When you try to measure the position of the particle to an higher accuracy, then there will be error with the momentum or uncertainty with the momentum or vice versa. So, this one it is told by Heisenberg in 1927. So, not only the position and momentum, he stated like this: there exists some pair of physical quantities in physics where you can't determine both the things simultaneously to a 100% accuracy. If you try to measure one, there will be uncertainty with the other. Later on further, he took a wave pocket, one wave pocket distance, and he derived the expression for Heisenberg, uncertainty. So that uncertainty expression later on it became the Heisenberg uncertainty principle. So according to that expression, if we have a delta x as the uncertainty in locating the position of the particle, and in the same direction if there is a delta p, the uncertainty in its momentum, then always the product of these two uncertainties or the errors, the product of these two errors will be always greater than or equal to h by 4 pi, where h is called the Planck's constant. Its value is 6.626 into 10 to the power of minus 34 joules second, and pi is constant. Okay. So, later on he showed delta x and delta p how it is. It is in linear distance and linear momentum. Same way you can consider the linear distance and linear momentum, that is delta L into delta theta or delta phi, which is also greater than or equal to h by 4 pi. So, when the object is moving in a circular path, then you need to consider this equation, that is delta L into delta theta is greater than or equal to h by 4 pi. Later on, we can show that the uncertainty with its energy and time also. So, this energy and time, delta E is the energy associated with it and delta T is the uncertainty in its time, which is also greater than or equal to h by 4 pi. So, here you can get this expression from this equation. Just I will show you simply how we can get that. So, as we know, the velocity v is equal to the change in its position, that is displacement. That itself, if we take it as the uncertainty in its position and its corresponding time as delta t, then you can write delta x is equal to v into delta t. This is one equation. And you know that the kinetic energy E is nothing but it is half m v square. Now, to this equation, if I multiply with m and divide by m, that is half m square v square divided by m. So, just multiply and divide by m, then you get this equation. Here m into v is nothing but momentum, hence it is half p square by m. You can write like this. So, now if I differentiate this equation, so differentiation of E is delta E, which is the uncertainty in its energy, which is equal to differentiation of p square is 2p into delta p, and in this equation 2 and m are constants. So, therefore, you can write them as it is. Now, this 2 will get cancelled and you can write momentum p as m into V into delta P, which is the uncertainty in its momentum, divided by m. So again mm get cancelled. So you get delta E is equal to V into delta P. Now you can substitute the value of delta P as delta E by V, and you can substitute delta x as V into delta T in the uncertainty equation, that is delta x into delta P along the x direction. This suffix indicates x, that means momentum is measured in x direction, because momentum is a vector quantity, so it should not be measured in other direction. Like delta x into delta Py, if I write, then it is not an uncertainty principle. There it is, you can measure both simultaneously, but in the same direction you can't measure. That also you should remember. So this is the uncertainty equation which we have. Here if you substitute delta x and delta P value, V get cancelled because V is in the numerator here and V is in the denominator here. So you will get directly delta E into delta T greater than or equal to h by 4 pi. Okay, so this is another form of Heisenberg uncertainty principle. In this, you can come to know that if you have two energy states, one is E1 and the other one is E2, the two energy states, then the difference in these two energy states you can take it as delta E, right? So if you know the delta E, then you can calculate what is delta T. That means any atom, if it excites due to a photon, if this atom excites by absorbing this radiation, that particular atom here, it can stay for about 10 to the power of minus 8 seconds. Within that it will come back. This is what we say. That means any atom excited in the excited state cannot reside in the excited state for a longer time. How you come to know that? That is by this equation. So here if you know E2 and E1 values, E2 minus E1 is delta E, substitute that delta E, then you can calculate delta T, how much T is. This is how the another form of Heisenberg uncertainty principle is delta E into delta T greater than or equal to h by 4 pi. So the physical interpretation of this Heisenberg uncertainty principle is you cannot measure these conjugate terms simultaneously. You can measure though both the quantities to the higher to the 100% accuracy at a different time, but not at simultaneously. The word simultaneously is important when you state the Heisenberg uncertainty principle. Okay? So Heisenberg uncertainty principle states that you can't measure position and momentum of a particle simultaneously to 100% accuracy. If we try to measure, then the uncertainty associated with the position and momentum, if you take it as delta x and delta px, then the product of delta x and delta px is always greater than or equal to h by 4 pi. This is what you need to remember.